Hello Year 5, happy Friday. Welcome to Friday's math session. Today we are looking at can I add fractions within 1? So all of the fractions we are working with today are going to be smaller than 1, lesser than 1. Okay, I hope you're excited. Let's first off do our arithmetic starter. Now this one here is going to use some fraction knowledge. Can you convert this improper or top-heavy fraction into a mixed number? You're going to need a whole number and a fraction. And over here, remember that this little 2 means squared. So it's 8 squared, take away 4 squared. Can you remember how to square a number? All right, I'm going to show you the answers in 3, 2, 1. Here we go. I hope you managed to find out that this is 6 wholes and 5 eighths. So that's 6 wholes and 5 eighths is your mixed number. Okay, and number 4, your answer should have been 48, which is 8 times 8, 8 squared, which is 64. Take away 4 times 4, which is 16, and that gives you 48. Well done, guys. Okay, let's start with a true or false. Okay, to add fractions, first make sure that the numerators of each fraction are the same. Do we need to make sure our numerators are the same when we are adding fractions? Really think about that. What part of the fraction is a numerator? What do you think, true or false? Let me show you. It is false. It's the denominator that we need to make the same. So the bottom of our fraction, that is what we need to make the same, because that represents how many parts in each whole. Okie dokie. Right then, so what do we need to remember about our denominator? Hopefully you haven't forgotten because we just talked about it. We need to make sure they are the same. So have a look at this question here. I've got 1/3 plus 1/6. And here, what I've done is I've split up my third. So I've drawn out my thirds and I've put them into 3 sections, but then I've added these lines here. Why do you think I've added those blue lines? Well, if you have a look at this bar model, this one has 6 parts because that represents 1/6. So all I've done is I've taken my 2 wholes and I've divided the top one up so that it matches the bottom. This is a physical representation of what we do when we make sure that these are the same. So if we were going to do it using our times knowledge, it would become 2, 6, because we would have timesed it by 2, because 3 times 2 is equal to 6. Okay, so how many parts do we have shaded in now? Once we've added these blue lines, how many parts do we have shaded in? Yep, we should have 3 parts shaded in. So 2 up here, 1, 2 here, and 1 down here. So how many is that altogether? That is 3/6. Now, can we simplify that down? What do you think? Is there a number that we can divide both by? What's the biggest number we can divide both 3 and 6 by? Yeah, we can divide them by 3. So our numerator is 3 divided by 3, which gives us 1. And our 6 divided by 3, because we've got to do the same to the top and the bottom, is equal to 2. So 3/6 is the same as 1/2. And we can also see that because 3 is half of 6. Okay, let's move on. Okay, your turn. How can we use our bar model to help us with this one? I've got the bar model for you here. You can draw it out in front of you on your books. Have a go. And then once you've answered this question, 3/4 plus 1/12, can you simplify your answer? I'm going to pause it here, and then I'm going to show you how I worked it out. Okay, 3, 2, 1. Okay, here is my answer. I've got 10/12. And what I did is I divided my top bar model, the one that represented 3/4, into 12, just like my bottom one. And then I moved my 1 from here and I coloured it in up here. Now all I needed to do was count how many parts I had in my whole. I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 parts. So my numerator is 10. And altogether my whole is 12. Now have a look at this one. Can we simplify our answer? Did you simplify yours? What did you need to divide this by? Each part, so you divided your numerator and your denominator by the same thing. What did you divide it by? I divided mine by 2, which gave me 5/6. And that is the simplest version of our answer. Okay, here is some part-whole models for you to have a look at. What do we need to remember about our denominator? I'm going to keep reminding you today, guys. It must be the same. So let's have a look at this one. We've got 5/12 and 1/4. Altogether, what is that going to be? Well, the first thing we need to do is make sure they have the same denominator. Now, I can't get this any smaller. I can't simplify this because it wouldn't match up to our 1/4. So this one is going to have to get bigger. We're going to have to times it by something. Now, what do we times by 4 to get to 12? Hopefully we've done this enough that this answer is like that for you. I'm going to times it by 3. So 4 times 3 is 12, and 1 times 3 is 3. So we're going to have 3/12. And now we can add them up, because what we need to do is we need to do 3 add 5, which is nice and simple. That is going to be 8. Do we need to add our denominators, or do they represent our whole, which is not going to change? Very good. It should be 8/12. Now, can we simplify that? Well, I know I can divide it by 2 because they're both equal, but I can also divide them by 3. By 3? No, not by 3. By 4. Wake up, Mrs. Rutherford. I can divide them by 4, so 8 divided by 4 is 2, and 12 divided by 4 is 3. And I can tell that because 8 is 2/3 of 12. So I'm going to put up here 2/3. And I could have put my 8/12 as well, but I decided to go for my simplest answer. Okay? Again, it's time for pausing. I'm going to pause, let you fill in this one for me, and then I will unpause and show you my working out. Hello, right, I realised I forgot to do my countdown, so I've covered up the answer just in case the video skipped ahead before you could pause it. Okay, now 3, 2, 1. Here is my working out and my answer. I knew that I'd need to make my denominators the same, so I had 4/12 because I times this one by 4. 3 times 4 equals 12, and 1 times 4 equals 4. I then added my 4 and my 5, so my numerators together to give me 9. So I had 9/12. Now, if you had 9/12 up here, fantastic, that is correct. But if you managed to realise that you could simplify it by dividing by 3, and that would give you 3/4, give yourselves a double thumbs up for spotting that simplification. Well done, guys. Okay, so this one is asking us to match the fractions with the additions that have the same answer. Now I'm looking at that and thinking, no, there's so many to work out. But actually, if you have a look at this column here, well, they've done half the work for us, because actually they've all got the same denominator of 12. So I'm going to go down here really nice and speedily and work out what these ones are. So I've got 10 plus 1 equals 11 over 12. That's it. 6 plus 1 equals 7 over 12. 9 plus 1 equals 10 over 12. Oh, I've got to have my finger catch up to my mouth sometimes. There we go. And 8 plus 1 is 9 over our denominator of 12. So we end up with, oh, they're getting bigger and bigger. 11/12, 7/12, 10/12, and 9/12. Okay, so what I want you to do is pause me here. Have a go at solving these ones. Now you should be able to work out which ones match, so you can match them up. And I will unpause and show you what I did in 3, 2, 1. Okay, here are my answers with my working out for you. Do they match yours? Have you spotted how to exchange them into common denominators here. Okay, here is a cheeky word problem. Now, I know that you will have smashed those word problems from yesterday, so this one is going to be really easy for you. Emma runs 7/20 of a route. Katie runs 2/5 of a route. It's the same route, so how much of the route do they run all together? So what are we going to need to add here? What addition is it asking us to do? Right, it's asking us to add 7/20 and 2/5. Now, can we do that straight away? No, we cannot. We cannot do that because otherwise our denominators will not be the same and it will give us the complete wrong answer. So what do we need to do to 2/5 or 7/20? That's a bit of a wonky 5 there. And 7/20. There we go. What can we do? Well, we need to make sure they have the same denominator. So we're going to do 5 times something to get us to 20. What do we need to times by 5 to get to 20? We need to times it by 4. So we're going to times 2/5 by 4. I'm going to do the same to the top and the bottom. So that is going to become 8. Whoop. What a weird 8. I'm going to rewrite that 8. 8. There we go. 20ths. And I'm going to cross this out so I don't get confused. Now, I'm going to do 8/20 plus 7/20 equals 8 plus 7, that's 15. So it's going to be 15/20. Right, now, so how much of the route did Katie and Emma run all together? They ran 15/20 of the route. Can we simplify that answer? Can we make it easier for us to use? Well, yes, we can. What's the biggest number that both of these are divisible by? What is their biggest common factor? It is 5, so we can divide this by 5, remembering to do the same to the top, the numerator, and the bottom, the denominator. And that gives us 3 over 4. So altogether, they ran 3/4 of the route, which is much easier to picture in our heads, isn't it? Fantastic. Okay, here is your varied fluency today. It's a lot of addition, but what I want you to remember is to simplify your answer if you can. What is the lowest common factor that you can use to simplify your answers down, if possible? Okay, then I want you to think about, can you spot any patterns in your answers? Is there a pattern in this box? And is there a pattern in this box? And if there is, what do you think would come next to continue the pattern? What calculation would come next? Okay, in 3, 2, 1, I'm going to show you the answers, but they are also on the website. Here are the answers. Now you can see that only one of them was able to be simplified. So I hope you managed to catch that this one could be simplified down into a half. Did you spot that pattern? Could you email me if you've spotted it today? Go and find your reasoning and problem solving on the website and have a brilliant day. Bye guys.